Astronomers around the world look for new planets in the distant solar system. As of October 22, 2021, scientists have discovered over 4,531 exoplanets. Meanwhile, there are 4,500 candidate planets that are yet to be confirmed. In 2005, astronomers discovered Gliese 581, a solar system with rocky planets like our own, with an estimated mass of around a third that of the Sun. Gliese 581 is the 89th closest known star to the Sun. Gliese 581, one among the oldest and least active M dwarfs. It has low star activity, meaning that its planets are more likely to retain large atmospheres and be spared from sterilizing effects of stellar flares than other M dwarfs. It has 4 orbiting planets with masses of about 1.9 for planet E, 16 for planet B, 5 for planet C, and 7 Earth masses for planet D. But there are still 2 unconfirmed planets, which is Gliese 581g and Gliese 581f. Both are disputed planets whether or not they exist or that they are within the Gliese planetary system. Astronomers are still investigating on the matter.
Gliese 581e is the closest one to its host star among the other planets, that completes its orbital period in 3.15 days. It is the 3rd planet discovered in the system and the first in order from the star. It has a mass of approximately 1.9 Earth masses, and it is said to be the lightest exoplanet found so far that is near a normal star and is extremely close to the Earth. Scientists believe that it likely has a rocky body like Earth, making it a terrestrial planet, but it is absurd for this planet to possess an atmosphere due to the radiation and high temperature coming from its star, and by that, it could not sustain life, and it is too close to the star for liquid water to endure the surface temperature.
The Gliese 581 planetary system now has 4 known planets, and one among them is planet B. Gliese 581 planet B is also known as Hot Neptune. It is an extrasolar planet orbiting within the Gliese 581 system and the first planet of 4 confirmed in the system so far. It is the second in order from the star. It has a mass of around 15.8 times that of the Earth, which is similar of Neptune's mass. Since it does not transit its star, its inclination is less than 88.1 degrees. Gliese 581b is 0.04 AU away from its star. Its mass, temperature, and together with Gliese 876d, its vulnerability to solar effects like coronal mass ejection are all expected to be similar to Gliese 436b. Gliese 581b does not transit.
In 2007, Gliese 581c, a super-Earth planet, was discovered. Early studies showed that Gliese 581c might have liquid water in its surface since it is in the habitable zone of its star. Studies suggest that it has a Venus-like environment. Gliese 581c was found using the radial velocity method. Gliese 581c was classified as Earth-like. However, actual conditions on the planet may be very different than our own. The radius of Gliese 581c is still unconfirmed. Gliese 581c takes about 13 days to orbit its parent star, a common belief that the planet is tidally locked. Furthermore, Gliese 581c is too hot to support life because it is so close to its parent star.
In the Gliese 581 planetary system, Gliese 581d is the third planet that is confirmed in the system. Assuming that Gliese 581 is a 5-planet model, this is fifth in order from the star. Gliese 581d is often shortened to GI 581d or GJ 581d, and this planet is approximately 20.4 light-years away in the Libra constellation. Its orbital period is 67 days with a radius of 14,016 kilometers and was discovered on the 24th of April 2007 by Stephen Audrey with an apparent magnitude of 10.55. This planet is thought to orbit on the cold side of the habitable zone. Unlike the Gliese 581c, it was too close to the star than it was on the hotter part.
Gliese 581g is a candidate for an extrasolar planet in the planetary system. However, its existence is strongly disputed at this time. The exoplanet, first announced in 2010 as a planet with a mass similar to Earth's in the habitable zone of its host star, has come under scrutiny as other research teams cast doubt on its discovery. Despite the fact that thousands of exoplanet candidates have been discovered, it usually requires at least 2 independent observations to determine that these worlds are real. The planets should be studied by 2 distinct teams using 2 different observatories in order to be scientifically rigorous. In 2012, the initial researchers that discovered Gliese 581g in 2010 defended their techniques and questioned the work of some of other teams.
Gliese 581f is another unconfirmed planet in the system. In 2010, the Lee Carnegie Exoplanet Survey announced its discovery. However, an analysis by European HARPS team concluded that this planet is unlikely to be in the system with a quoted characteristic. Studies published in 2011, 2012, and 2013 tend to view that Gliese 581f as well as Gliese 581g do not exist. Gliese 581f would have a mass of at least 7 Earth masses and orbit at a distance about 113 million kilometers, over 70 million miles, once every 433 days.
The star Gliese 581 is a very ancient one. It is relatively inactive due to its sluggish spin, making it a potential habitable planet candidate. Due to its low mass than the Sun, Gliese 581's core region fuses hydrogen at a much slower rate than the Sun's. Gliese 581 A, B, and C have circular orbits, whereas Gliese 581d, assuming it exists, has elliptical orbits. Some of the planet's surface is tidally locked to the star, meaning that one side of the planet is always facing the star and basking in constant sunlight, while the other is always in the dark.
Gliese 581 is discovered based on 11 years of observation with the Keck-1 telescope's higher spectrometer. The spectrometer can determine a star's radial velocity, which can show the presence of planets. The catalog number Gliese 581 comes from the Gliese Catalog of Nearby Stars, a 1957 survey that found 965 stars within 20 parsecs of the Earth.
Gliese 581 evolution theory is the same as the protoplanet hypothesis. Gliese 581 was formed because of the gravity that draws a cloud of dust and gas together and causes it to rotate. When the material reaches the critical temperature, it clusters in the middle. Furthermore, the protoplanet is a theory that the planets were made of a whirling cloud of gas and dust during the formation of a solar system.
Everything is unique, and that also includes Gliese 581. Though it may not sound like a weakness, one trait about this system is that Gliese 581 has low luminosity, and because of that trait, a planet would have to be significantly closer to the star to receive the same amount of energy as the Earth. Another weakness we could think of is that the data we got from official government sites and Wikipedia pages might be wrong because this is a star that is 20.22 light years away from us. The data recorded by different scientists may differ from each other, which may cause a lot of misunderstandings towards the planet and its data.
When it comes to adjusting for the sun's activity, a team led by Paul Robertson, a postdoctoral scholar at Penn State University, declared in 2014 that Gliese 581b, another planet in the system, is not observable. The presence of Gliese 581g can be inferred from Gliese 581d's orbit. If 581d isn't present, neither is 581g, according to the researchers.
Is the solar system unique or rare? To answer the question, yes, the solar system is unique in its own way, but we can find almost similar systems in the universe. Although our solar system is the only known planetary system, other stars in our galaxy have been discovered orbiting other planets. Many other civilizations, many planets like Earth, are likely to exist in the Milky Way. Astronomers have discovered hundreds of solar systems, with more being discovered every year, and the solar system is only one of the many planetary systems in the universe.
What is the possibility of finding a similar system within the Milky Way galaxy? The possibility of finding a mirror-like solar system in the Milky Way galaxy is 100%. Astronomers have found more than 500 solar systems and are discovering new ones every year. Given how many they have found in our Milky Way galaxy, scientists estimate that there may be tens of billions of solar systems in our galaxy, perhaps even as many as 100 billion.
What about an Earth-like planet? It is possible to find an Earth-like planet within the habitable zone by using astrometry in the transit method. There are hundreds of newly discovered planets out there, and there is a high possibility